In this very lesson, we shall be looking at the binomial theorem. Binomial theorem. But before that, let's look at what binomial means. When you have an expression of the form, then this expression is called a binomial expression. This means that when you have any two terms connected with the addition or the subtraction sign, then that expression becomes what? A binomial expression. Examples of binomial expressions are A minus B is a binomial expression because it contains two terms, the first term, the second term, connected with the subtraction sign. Another example is x plus y. This is also a binomial expression because it contains two terms connected with the addition sign. We can talk of this is also a binomial expression. We can also talk of this is also a binomial expression. There are lots and countless examples of binomial expressions. Now, how do we expand a binomial expression to a certain power? So let's take it that you have the binomial expression a plus b raised to the power 2. How do we expand this binomial expression to the power 2? Now, I believe that to expand this, we can rewrite this as. So after rewriting this as this, then we apply our distributive property to expand the bracket. So let's do that. So we are going to have A multiplying the whole of the second bracket plus B multiplying the whole of what? The second bracket. So we have A squared plus AB plus what? B squared. Then after that we simplify. This is going to give us A squared plus 2AB plus what? B squared. This is how we expand it. And after expanding and simplifying, this is what you are going to have. Now, what if or what about when you have a binomial expression to the power of, let's say, A plus B raised to the power 5? How then do you expand a binomial expression to the power of 5? Or let's say higher powers, let's say power 6, power 7, power 8, power 9, and so on. You realize that in expanding this using the distributive approach here becomes more stressful and then tedious to expand it, because you are going to rewrite this 5 times and then you are going to expand it one after the other. You see that it becomes more stressful and tedious. If that happens, then we need a more powerful approach or method to enable us to expand a binomial expression to higher powers with ease or without any stress. Then this calls for what we call the Pascal's triangle. Pascal's triangle. Pascal's triangle. So when we talk about the Pascal's triangle, it's just the arrangement of numbers that represent the coefficient in the expansion of any binomial expression. So with the previous example that we did, we had A plus B raised to the power 2. When we expanded this, we had A squared plus 2AB plus B squared. Now when we talk about coefficients, we are referring to numbers in front of variables. And when we talk about variables, we are referring to the letters of the alphabet. So we have variables, variables, variable. Now the coefficients are what? The numbers in front of these variables. So with this, we have the variable 2. Now remember, every variable has the number 1 written in front, but actually we don't write it. So when any variable is standing alone without any coefficients, there is 1 in front, but we don't write it. So with this, it means that we have 1 in front, but actually we don't write 1a squared. This we have 1 in front. Actually, we don't write 1b squared. So the coefficients for these expansions are 1, 2, 1. So we have 1, 2, and then 1. Also, when you have a binomial expression, a plus b raised to the power 1. Actually, we don't write raised to the power 1. So I can clean it. So when you expand this, you are going to get a plus b. What are the coefficients of this expansion? You know that every variable standing alone, there's 1 in front, but we don't write it. So we have 1, 1. Therefore, the coefficients are 1 and then 1. Also, when you have the binomial expression raised to the power 0, you know that any number or any variable raised to the power 0 gives us what? 1. So this raised to the power 0 is equal to 1. Therefore, the coefficient of this is 1. So these are the coefficients of the binomial expression with their respective power. So these are the coefficients, the numbers in front of variables. Now, obtaining the coefficients of a binomial expression with their respective power follow a certain pattern. It follows what? A certain pattern. And we are going to use this pattern to write down all the coefficients of a binomial expression with a given power. We are going to use or based on this pattern form to write down all the coefficients of a binomial expression with a given power. So let's do that. So these are the binomial, and then we are going to look out for their coefficients. So we know that a binomial expression with a power of 0 is going to give us a coefficient of 1, because any number raised to the power 0 is 1, any variable raised to the power 0 is 1, so we have 1. Now with the pattern, what we are going to do is that every subsequent row, that is the next row after this, always starts with 1 and then ends with 1. And then in between the 1, each number is obtained by summing the two numbers directly above it. These are the two things that we are going to use in forming the coefficients of this binomial expression with their respective powers. So with this, we have 1. So we are saying that each subsequent row starts with 1 and then ends with what? 1. So we have it start with 1 and then end with 1. Let me write a small 1 and then end with 1. So it means that when we expand a plus b raised to the power 1, we have 1 and then 1. Now let's move on to a plus b raised to the power 2. So we are saying that every subsequent row starts with 1. So it starts with 1 here and then ends with 1. Now each interior numbers are obtained by summing the two numbers directly above it. So it means that to obtain this number, we are going to sum the two numbers directly above it. 1 plus 1 will give us 2. We are done. So when you realize that when we expanded this, we have 1, 2, 1. So we had 1, 2, 1. Now let's move on to this. So every subsequent row starts with 1 and then ends with 1. Now every number in between, or each interior numbers in between, is obtained by directly summing the numbers above it. 1 plus 2 give us 3. 2 plus 1 will give us 3, and then we have our 1. Now let's move on to raised to the power 4. Every subsequent row starts with 1 and then ends with 1. Now each interior numbers are obtained by summing the numbers directly above it. So we have 1 plus 3 will give us 4, 3 plus 3 will give us 6, 3 plus 1 will give us 4, and then 1. Then let's look at the last one. A plus B raised to the power 5. So realize that every subsequent row starts with 1 and then ends with 1. Then we add this. This is going to give us 5. This is going to give us 10. This is going to give us 10. This is going to give us what? 5. So these are the coefficients of this binomial expression with their respective power. So when you have a binomial expression with a power of 3, the coefficients are 1, 3, 3, 1. With a power of 4, we have 1, 4, 6, 4, 1. And then with a power of 5, we have 1, 5, 10, 10, 5, 1. Remember, this is not the end. We can continue to the power of 6, 7, 8, 9, 10, and so on. You can continue using the same pattern. Now you realize that the shape of these coefficients looks like what, or resembles a triangle. And therefore, the pattern created by this coefficient is what we refer to as what, the Pascal's triangle. It was named after the man Pascal who came out with these coefficients. Now that we can come out with the coefficient of binomial expression with their respective powers, we are going to take examples and see how best we can apply this to expand a binomial expression with a given power. So we have the steps that is going to guide us to apply the Pascal's triangle in expanding a binomial expression with a given power. So we have find the number of terms using what? The formula n plus 1, where n is the power of the binomial expression. To write down the coefficient of the binomial expression, we have to write all the coefficients of the binomial expression with regards to that particular power. And then third, write down the expression with the binomial coefficient, and then you simplify. So we are going to take examples. So we have a plus b raised to the power 2. We want to expand this. Using the Pascal's triangle. Now the first step is that find out the number of terms using the formula n plus 1. So we are first going to find the number of terms. So we have number of terms. We have n plus 1, where n is the power of the binomial expression. So we have 2. We have 2 plus 1, and that's going to give us what? 3. So it means that after expansion and then simplification, we should have how many terms? 3 terms. So it means we are going to have what? 3 terms. And then the second step is that we have to write the coefficient of the binomial expression with the power of 2. We have what? 1, 2, 1. So when you have a binomial expression with a power of 2, the coefficients are 1, 2, 1. I believe you are following. And then the last step says that write down the expression with the binomial coefficient. So we are going to write the expression with the binomial coefficient. So what we are going to do is that we are first going to write the coefficients. 1, we leave a space. 2, we leave a space, and then 1. Because we are going to fill this space with what? The expression for that. Now after writing this, what we are going to do is that we know that this is the first term, and this is what? The second term. Now with the first term, it always carries all the power of the binomial expression. So it means the a is going to carry the whole of the power. So we are going to have a raised to the power 2. And then the second term takes a power of 0. It takes nothing. So the second term is b, is going to take a power of 0, which is nothing. Now after having this, now what we are going to do is that the power of the first term decreases in that order, and the power of the second term increases. So as the power of the first term A decreases, the power of the second term increases. So we bring our plus here. Now the power of the first term decreases, so we are going to have A raised to the power 1. It decreases in that order, and then the power of the second term increases. From 0 we move towards 1, so we have B raised to the power 1. Now always the summation of the powers of the two terms must be equal to the power of the binomial expression. So if you look at this one, 2 plus 0 we are having 2, 1 plus 1 we are having 2. Good, let's continue. Now the power of the first term decreases, so from 1 it moves towards 0, so we have A raised to the power 0. And then B, it increases, so from 1 we move to a 2. Now after that, let's simplify. 1 times A power 2 will still give us A power 2. Any number raised to the power 0 is 1. So we are going to have A squared times what? 1. And then we have plus 2 AB plus A raised to the power 0 is 1. So we have 1 times what? B raised to the power 2. Let's simplify further. A squared times 1, we have A squared plus 2AB plus what? B squared. And that is that. So this is the expansion that we are going to have using the Pascal's triangle when we expand a binomial expression with the power of 2. And I believe that you can remember that with the first example that we had, this is what we had. This is the answer that we had. Let's take our next example. So we have our second example, x plus 3y raised to the power 3. So you know that this is our first term, this is what? Our second term. Good. So we are going to follow the same steps. We find the number of terms that we are going to get when we expand this binomial expression with a power of 2. So you know that to do that, we are going to use the formula n plus 1, where n is the power of the binomial expression. So we have 3 plus 1, and that gives us what? 4 terms. So after expansion and simplification, we should get what? 4 terms. Then the second step says that we should write all the coefficients of the binomial expression with this very power. So a binomial expression with a power of 3, the coefficients are going to be 1, 3, 3, 1. These are the coefficients of a binomial expression with a power of 3. Good. Now that we have the number of terms, the coefficients of the binomial expression with a power of 3, we are going to write down the terms together with the coefficients. So as I said, we are going to first write the coefficient 1, we leave a space, we have 3, we leave a space, we have 3, we leave a space, we have 1. Then after that, we fill these spaces with the expressions. So as I said earlier on, the first term always carries the whole power of the binomial expression. So we have x is going to carry the whole of that power, which is what? 3. And then the second term, which is 3y, takes a power of what? 0. So we have 3y raised to the power of what? 0. Then after that, we'll bring our addition sign. As I said earlier on, to verify, the summation of the powers must be equal to the power of the binomial expression. It must be equal to that. So we have 3 plus 0 is equal to that. Then the power of the first term decreases in that order, whilst the second term increases in that order. So we have power 3, it will move towards power 2. So we have x raised to the power 2. It has decreased to power 2. And then 3y power 0 will increase to power 1. So we have 3y raised to the power 1. We bring our addition sign, x will decrease to 1, whilst 3y will increase to what? 2. We bring our addition sign. X will decrease to what? 0. You have x power 0, whilst 3y increases to what? Power 3. Always after writing this, check to see if the summation of the powers of the two terms is equal to the binomial expression, the power of the binomial expression. So you have 2 plus 1, 3, 1 plus 2, 3, 0 plus 3, 3. We can continue. So we have our equal to. Now let's simplify. 1 times x cubed will give us x cubed. 3y power 0 is what? 1. Any number raised to the power 0 is 1. So we are going to have x power 3. Now we have 3 x squared, and then 3y raised to the power 1 is 3 what? 3y. And then we have 3 x power 1 is 2x, and then 3y raised to the power 2. We are going to get what? 9y squared. Now this is the same as 3y times 3y. 3 times 3 give us 9. Y times y will give us what? Y squared. 9y squared. Good. Then we have, this will give us 0. This will give us 27y power 3. So this is the same as 3y. 3y raised to the power 3 is the same as this. So we have 3 times 3, 9. 9 times 3, 27. So we have 27. Y times y squared times y cubed. We have y cubed. That is what we have here. Now let's simplify further and see what we are getting. This is going to give us x power 3 plus 3 times 3 will give us 9 x squared y. Then we have 1, plus this will give us 27 x y squared plus 27 y cubed. Very, very, very simple and then easy. Very, very simple and then easy. Let's try our hands on the last example and then away back. So we have our last example. Obtain the expansion of the binomial expression 2x plus 1 over 2 raised to the power 4 using the Pascal's triangle. We are going to follow the same steps, this one, to expand this binomial expression. So we have our solution. So the first thing, we have to find the number of terms using n plus 1, where n is the power of the binomial expression. So we have 4 plus 1. That gives us what? 5 terms. So after expansion and then after further simplification, we should get what? 5 terms. And then after that, we write the coefficients. Coefficient with the binomial expression of with the power of what? 4. So we are going to have 1, 4, 6, 4, 1. So this means that when you have a binomial expression with a power of 4, these are your coefficients. So after that, we are going to write the coefficient with this expression. So we are going to have 1 equal to, so we have 1, we leave a space, 6, we leave a space, 4, we leave a space, 1, 4, 1, 4, 6, 4, and then 1. And after that, we fill each spaces with the expressions. So as I said earlier on, the first term always carries the whole power of the binomial expression. And we know that this is the first term. This is what the second term. So the first term carries the power, the whole power of the binomial expression. So we have 2x raised to the power 4. While the second term takes the power of 0. 1 over 2 takes the power of 0. Then after that, we bring our addition sign. After doing this, now the power of the first term, which is 4, decreases in that order, whilst the power of the second term increases in that order. So we are going to have 2x raised to the power of 3, and then 1 over 2 increases from 0 to 1. We have our plus. We have the first term 2x decreases towards 2, while the power of the second term increases to where 2. Then move to this part. The first term power, which is 2, it decreases to 1, whilst the second term power increases to 3. Then we have our plus. So the first term power decreases to 0, and then the second term power increases to 4. Now after this, check and see if your powers are really right. The summation of the powers of the two terms must be equal to the power of the binomial expression. 4 plus 0 is still 4, 3 plus 1 is 4, 2 plus 2 is 4. So we are on the right path. Let's continue. So the rest is simplification. 2x power 4. Now 2x power 4 is the same as 2x times 2x times 2x. 1, 2, 3, 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Now we have x, 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 x. 1, 2, 3, 4. Indices, when the bases are the same, we pick one of the base, we add their exponents. So we are going to have 16x power 4. Then we bring our addition sign. We know that any number raised to the power 0 is 1. 1 times it is still that. Then move on to this part. We have 4. 2x raised to the power 3. We have 8x raised to the power 3. 2x raised to the power 3 is the same as 2x times 2x times 2x. 2 times 2, 4. 4 times 2, 8. Then x times x, x squared times x squared, x. So we have x cubed. 1, 2, 3. In this is when the bases are the same. You pick one of the base, you add their exponents. Now once you are done, we are left with what? Half raised to the power 1 is still what? Half. So we have our 6. 2x raised to the power 2, we have 4x squared. This is going to give us what? 1 over 4. 1 over 2 squared is the same as 1 over 2 times 1 over 2. This will give us 1 all over what? 4. So we have 1 over 4. Then we have plus 4. 2x raised to the power 1 is still 2x. And then 1 over 2 raised to the power 3 gives us 1 over 8. This gives us 1 over 16. Now let's do further simplification. So we have 16x power 4 plus 4 times 8 will give us what? 32x cubed. And then we have half, we can rewrite it as that. And then we have 6 times 4 give us 24 x squared times 1 over 4 can be written as this. Plus 4 times 2 give us 8x. We can rewrite this as what? Over 8. And then plus 1 over what? 16. Now let's do some cancellation here. We have 16x power 4. 2 into 32, we are having what? 16, right? So we have 16 x cubed plus 4 into 24, we have 6 x squared. 8 into 8, we have x, and then the last one we have 16, and that is that. So this is the expansion form of the binomial expression with this no power. This brings us to the end of today's lesson. I'm going to give you some tutorial question. Pause the video, you try your hands on it. So see you tomorrow. Bye bye.